Today, I'm very glad to have a talk titled Consideration on how to apply multiple FAPI and its related security profiles dynamically. Before my talk, let me introduce myself to you briefly. My name is Takashi Norimatsu, working at Open Source Solution Center Hitachi Limited, Japan. I've been engaging in providing support services about open source and also implementing and contributing some features to open source, especially the Keycloak, the identity and access management software. Today, I would like to talk about the following items. At first, I would like to tell you the main theme of this talk. And also, I'd like to tell you the formal definition for some technical terms that would be needed to understand today's talk. And next, I would like to tell you the decision points I've encountered when I implemented FAPI and its related security profiles to open source. Also, I would like to tell you the problems that may arise due to this decision option. And next, I would like to propose its resolving for these problems by introducing attribute-based access control, ABAC perspective. And finally, I would like to wrap up this talk by telling you my short conclusion. So let's move on to the first part. Main theme of this talk is to tell you the decision point I've encountered when I implemented security profiles, the FAPI, and its related security profiles to open source. There are two such kind of decision points. Whether to apply multiple security profiles at once against the client's request or single security profile. The decision point 2, whether to allow a server to change the different security profiles onto the request from the same client dynamically in its context, depending on its context. Before talking about that, I would like to define some technical terms. Security profile. What is security profile? I've not yet found a formal definition for security profile. So therefore, I would like to put its working definition, a security specification that is based on security standard and include requirements to satisfy a specified security level. For example, FAPI 1.0 baseline and FAPI 1.0 advanced security profile. So FAPI CIBA security profile and best current practice OAuth for native application, open banking Brazil FAPI 1.0 and so on. Of course, we can create our own security profiles to meet our own use cases. And next, what is applying a security profile? I've also not yet found out formal definition for it. So therefore, today I would like to put a working definition for only this talk. What does apply a security profile means? On receiving the request from the client, OAuth server checks this request content to find out whether to satisfy the requirements by the security profile and send back to the client the response as the security profile describes. Also, I would like to tell you the characteristic of OAuth 2 client. Due to the nature of OAuth 2 client, there is client metadata concept. It describes a client itself. Also can be used to process a request from the client by authorization server. I think there are two types of client metadata. Ones are defined by standard specification, for example, RFC 7591 OAuth 2 dynamic client registration protocol. And others are a software product specific client metadata. Sometimes it is called as client settings. Today, I would like to use the word client metadata to represent this concept. Also, I would like to make an assumption for this talk. As I mentioned before, just before, the authorization server processes a request from the client based on its client metadata. So, I think the straightforward ways for applying a security profile is that at first, the server and or client found out an appropriate and valid set of values to client metadata that satisfy the requirement by standard by a security profile. And actually, the server and client or end client set these values onto its client metadata. And the server process this client request based on this client metadata value. By doing so, the server can apply security profile to this client's request. If the existing client metadata and its corresponding the logics cannot meet some security profiles, the new client metadata and its corresponding logics might be added to the OAuth server. So up to now, I've described the main theme of this talk and also technical terms definition that would be needed to understand today's talk. And next, I'd like to talk about a decision point I've encountered when I implemented FAPI and its related security profiles to OAuth. There are two such decision points. At first, I would like to talk about the former one, whether to apply multiple security profiles at once against the client request or only single security profile. I've investigated FAPI and also its related the security profile family. Here, I'd like to pick up such four security profiles: FAPI 1.0, baseline advanced, FAPI Silver, and Open Banking Part 0 FAPI 1.0. As its name suggests, the FAPI 1.0 baseline is the basic component for all other three security profiles. FAPI 1.0 advanced is generally based on FAPI 1.0. FAPI 1.0 advanced is generally based on FAPI 1.0, baseline. And FAPI receiver is generally based on FAPI 1.0 advanced. And OpenBanking Brazil FAPI 1.0 is generally based on FAPI 1.0 advanced and also FAPI receiver optionally. Therefore, of course, we can see the such security profile as single self-contained security profile. For example, I'd like to pick up the Open Banking Brazil 1.0 security profile here. It contains all of the needed part. But however, it can be seen as the set of other security profiles. I would like to call it the single security profile option, and I would like to call it the multiple security profile option. So, which is appropriate? From the point of capability, I think both can do the same thing. However, from the point of maintainability, multiple option might be preferable because the single security profile option introduces some additional managerial cost because some security profile includes duplicated part with other security profiles. However, if applying the multiple security profile option, the problem may arise, namely the conflict or anomaly among several security profiles applied at once against the client's request. For example, here I'd like to pick up such security profile A and security profile B. All server reject all requests of the client due to the nature of these security profiles. So I think such kind of the problems should be resolved, and I would like to talk about its resolution afterwards later on this talk. So next, I would like to the other decision points. Whether to allows our server to apply security profiles per request or per client. Applying security profile per client means that authorization server applies same security profile against every request from the same client. For example, here, the auth server apply FAPI 1.0 baseline onto the request from every request from the client to one, while auth server applies FAPI 1.0 advanced security profile onto every request from client to, I'd like to call it per client option. Then the applying security profile per request means that auth server change the security profile that should be applied to the request from the client dynamically based on this request context. Here, I would like to use the example. There is a client, and this client wants to access two types of API. One is the API providing the resource owner's bank account transaction history, and the other is the API initiating payment services. The former API access might be protected by FAPI 1.0 baseline, while the latter API access should be protected by FAPI 1.0 advanced security profile. I would like to call the former API the read API, while the latter API called write API. In this case, the auth server applies FAPI 1.0 baseline security profile onto the request from the client with scope or the authorization details representing accessing read API, while auth server applies FAPI 1.0 advanced security profile onto the request from the same client, which with the scope or the authorization details representing accessing write API. Then a client option may do the same thing by the per request option. I would try to explain how to do that. I would like to use the example I've just mentioned before. The client wants to both two type of the APIs, read API and write to API. Then client instantiate the two clients, client 1 and client 2. And so client 1 is used for accessing the read API, while client 2 is accessing for write API. The server apply FAPI 1.0 baseline onto the every request from this client 1, while the server apply FAPI 1.0 advanced security profile onto the request from this client 2. But however, this per client option introducing some managerial cost. Auth server, in this case, the auth server need to manage two clients, client 1 and client 2. So, considering that point, it might be preferable to apply a per request option. But there are other ways for doing so. In this case, the client does not need to instantiate client 1 and client 2 for each the security profile. Instead of that, the client, if the client wants to access the read API, then before sending the request to the server, the client tries to send a request that modify its client metadata that meet FAPI 1.0 baseline security profiles requirements. After it is completed, client actually sends the authorization request to the server. And after that, if the client wants to access write API, then client at first send the request to the server that tries to update its client metadata that meet the FAPI 1.0 advanced security profile requirements. After it is completed, the client sends authorization request to the server. And so by doing so, the per client option can do the same thing by the per request option. But however, From the point of maintainability, it introduces the additional communication overhead between client and authorization server. Therefore, it might be preferable to apply per request option. But however, applying the per request option may cause some problem. In some cases, the authorization server rejects a valid request from the client that meet the requirement by some security profiles. This problem arise. The reason why this problem arise is that, as I mentioned at the beginning of the talk, the author process a request from the client based on its client metadata. And there are some client metadata that can meet the requirement by some security profile, but does not meet the requirement by other security profiles. I would like to talk about these problems later on in detail and also propose its resolution onto the next part. Up to now, I've describes the decision points I've encountered when I implemented security profiles, FAPI security profiles, and its related security profiles to the open source. Also tells you the problems that may arise due to the introducing such decision point. And in the next part, I would like to propose its resolution by introducing ABAC attribute-based access control perspective or applying a security profile. I would like to describe the core concept of ABAC. As you may know, there are three entity or component: subject, object, and environment or context. Each has its own attribute. Then the policy concept that determines whether an access request is accepted or not based on these attributes. Then I would like to propose the ABAC-based security profiling, incorporating this core concept of ABAC. ABAC-based security profile, there are three basic entity: client and request, and environment or context. Then each entity has its own attribute. And client attribute is regarded as client metadata. The reason why I will introduce ABAC perspective is to try to resolve the two problems I've just mentioned before. For problem one, if we allows the observer to apply multiple security profiles at once against a request from the client, the conflict or anomaly among security profiles may arise. I expected that I could use the existing ABAC result to detecting and resolving conflict and anomaly among policies. Then for problem two, if we allow our server to change the security profiles dynamically, depending on its context against the same client's request. In some cases, the OAuth server may reject the valid request from the client. By using the nature of the policy concept in ABAC, I can enforce the logics regardless of client metadata's value. I'd like to describe these points in detail afterwards. Before talking about its detail, I'd like to more describe compare the proposed ABAC-based security profile model with the actual implementation of ABAC. Here, I've picked up extensible access control markup language as such the implementation. It takes the one-phase decision, while the ABAC-based security profiles takes two-phase decision strategy. There are two component policy and profile in ABAC-based security profile model. Policy determines which security profiles is applied to which client's request, while the latter phase profile determines whether the received client's request satisfies the requirements by security profile or not. By taking two-phase strategy, it might be easy to change existing profile, modify existing profile, and add new security profile onto this model. Then, some ABAC ABAC research papers stated that there are several kinds of the policy. And here, I would like to describe two types of the such policy in the context of ABAC-based security profile model. Here, there are two types policy: authorization policy and constraint checking policy, or constraint policy. Authorization policy is applied to a request from the client regarding to authentication and authorization protocol flow. For example, authorization request, token request, and so on. While constraint policy or constraint checking policy is applied to a request, client's request that tries to register, modify, delete client itself or client's metadata. Here, I would like to tell you how the authorization policy works in ABAC-based security profile model. Compared with the existing client metadata-based logic, I've just put as an assumption at the beginning of my talk. For example, I picked up the client metadata PXE code challenge method. It is not standard client metadata. Then, the ordinary client metadata-based logic. The OAuth server process the client's request to check the PXE, the requirements. While in the case of the authorization policy based logic, the OAuth server checks the PXE requirements against the request from the client, regardless of client metadata's value. Therefore, it might be okay to say that authorization policy-based logic can override the existing client metadata-based logic. Next, I would like to talk about the constraint checking policy and constraint policy, how these policies works in the context of ABAC security profile model. Let's consider the situation that the client the client and the authorization server want to apply FAPI 1.0 advanced security profile. Then the client tries to send the request client metadata updating request to the OAuth server with TLS client certificate bound access token to be false. Then the constraint checking policy logic reject this request because this current metadata value does not satisfy the requirement by FAPI 1.0 advanced, while the constraint policy based logic accept this request, but however set this current metadata value to true, not false, and send back to the client successful request, but notifying the client of it, changing the client metadata value. So those are the several kinds of security, several kinds of the policy, and how those works in the context of ABAC-based security profile model. Then the next, I'd like to talk about how to resolve the problems by using a ABAC-based security profile model. At first, for problem one, resolving the anomaly or conflict among security profiles applied at once against the client's request. To tell the truth, it's still open question. I expected that I could use the existing result of ABAC research paper try that treating anomaly or conflict detected and resolution, but however, I've not yet found out an appropriate and general way of doing so. Therefore, this problem cannot be resolved. So the still open question, then I would like to study this problem in the future. Then problem two, sometimes the client, the OAuth server reject the client's valid request. By using the concept of the policy in ABAC, I can enforce some logic against the existing client metadata-based logic. So I would like to describe this point by using the same example. And the client want to access both read API and write API, and client tries to send the request to the OAuth server, token request to the OAuth server under mutual TLS. Then the authorization policy based logic check this request and issue the sender constraint certificate bound access token and send bucket to the client. Why? So if the client wants to access the read API and send the token request to the OAuth server under ordinary TLS, then authorization policy based logic accept this request and issue bearer token and send it back to the client. The client metadata-based logic may reject this request because this client didn't send client certificate to the auth server under the mutual TLS handshake. But however, the authorization policy-based logic can successfully accept this valid client's request. Considering that point, I would like to take the three options and consider which option might be appropriate to which situation. Then at first, option 1. It is the same as the assumption I made at the beginning of this talk. Auth server process the request from the client based on its client metadata. For example, in this slide, FAPI 1.0 advanced security profile should be applied. So its client metadata's value must be set to meet these requirements by FAPI 1.0 advanced. The next option 2, using constraint policy. This option 2 takes advantages against option 1 because authorization server enforces valid client metadata value that meet the security profiles. In option 1, the client or auth server may set the invalid client metadata value that does not meet the security profile. This option 2 can prevent this situation. Finally, the option 3, the using authorization policy based logic. Option 3 takes the advantages against the former 2 options. This option 3 can change security profiles dynamically based on the client request context. Then here, I would like to consider the 4 situations that I've talked about at the beginning of this talk. Whether to apply multiple security profiles at once against client's request or single security profile, and whether to apply security profile per client or per request. I conclude that applying single security profile for every request from the same client. In this situation, option 2 might be appropriate, but however, in other 3 situations, option 3 might be appropriate because the option 3 can can override the client metadata-based logic. That can the client metadata logic, therefore can change the dynamically security profiles against client from the same against the request from the same client. But however, if the tries to apply this ABAC-based security profile model in commercial services, we need to consider the other points. For example, the policy management, policy audit, bootstrapping, and so on. Then finally, I would like to wrap up this talk by telling you the conclusion of this talk. On this talk, I've described the addition points I've actually encountered when I implemented FAPI and its related security profiles to open source. There are such kind of the 2 decision points, whether to apply multiple security profiles at once against the request from the client or single security profile. Then, problem whether to apply security profile per request or per client, namely whether to change security profile that should be applied to the request from the same client dynamically in a based on its current request context. And I've also talked about the problems that we may encounter due to these decision points. And I've proposed the one ways of resolution by introducing ABAC perspective proposing the ABAC-based security profile model incorporating the core concept of ABAC. And I expected that the existing ABAC research papers, the work, can resolve one of these problems, but however, I've not yet found an appropriate solution. Therefore, there is one open question for resolving, detecting anomaly and conflicting among several security profiles that might be applied at once against a client's request. And also, there is other open questions. If tries to apply ABAC-based security profile model in commercial services, there are other points need to be considered. For example, policy management, policy audit, or bootstrapping, and so on. Oh, sorry. That's all for my talk. Thank you very much for your listening. I'll be very happy if you have some comment or the question about this talk.
Thanks a lot, Takashi. Are there any questions? Peter, you're applauding or raising the hand?
Yes, I have no question.
Okay. Anybody else?
Yes, I do have one question. Which criteria shall we apply to determine which profile is suitable for a given use case? Do we have any such policy?
I beg your pardon. Could you please?
Yeah. What is the basis of choosing profile for a given use case?
What is the choosing of the security profile?
Yeah, there are some use cases. Say in a banking use case.
Yes,
in a banking use case, if I need to choose a profile among several, which criteria shall we opt for? Shall we go with?
I'm very sorry. I couldn't listen to you what you said. In banking.
Maybe I can try to repeat the question. I think the question, if I understood you correctly, was how to choose which profile to apply. Right?
Okay. Okay, I see. How about what we are talking about in the banking use case or other use case?
Yeah, in a banking use case.
Banking use cases, and in banking use cases, which security profiles might be appropriate? Is that right? Is your question?
No, there are FAPI SIBA profile, FAPI 2.0 profile. So suppose let's consider for example, for the sake of discussion, these two profiles. Then which profile shall we go with for a given in a banking use case? Shall I go with FAPI SIBA or shall we alone go with FAPI 2.0? Does it make sense?
Yes, I see. Now, there are several FAPI-related uses, FAPI-related security profiles, and which FAPI-related security profiles might be applied to in the use case of the, for example, banking use case. For example, in which cases whether the FAPI server is appropriate or not, and so on. Is that a question?
I don't know whether I followed you. Let's take an example of say there are a couple of there is in a banking use case money transfer, fund transfer. Let's take an example, fund transfer. And in the fund transfer, yeah, we should go with a very high graded security, right? In that case, we should, whether shall we go with FAPI SIBA profile or shall we go with FAPI, the advanced one?
I think in my opinion, FAPI SIBA might be appropriate. But yeah, in my opinion, in this case, the FAPI SIBA might be appropriate instead of simple FAPI 1.0 advanced.
Okay, thank you.
Maybe I can add to that as the editor of the FAPI 2 spec. So in general, there's the question whether to go for FAPI 1 or FAPI 2 series of standards. And the general guidance that the OpenID Foundation gives is that if you have a new implementation, it makes a lot of sense to go for FAPI 2. But if you have any considerations to make because you already have a implementation, or if you have to take certain vendor products that only support FAPI 1, then it is also fine to go for FAPI 1. So it is both considered a good and secure standard. FAPI SIBA is a bit special because it allows for the special client-initiated backchannel authentication flow. So that is a special kind of flow, and that really depends on your use case.
Yeah, Daniel, thank you. I followed what you said. So FAPI SIBA, so backchannel authentication, there is some backchannel authentication in SIBA. So going with FAPI SIBA is the best option if we have to choose among FAPI 1.0, FAPI 2.0, and FAPI SIBA.
So FAPI SIBA is not directly an alternative to 1.0 or 2.0. FAPI SIBA was developed for 1.0. You can also see it here on the screen. So it's essentially based on FAPI 1.0. But you can also use FAPI SIBA with 2.0. So you use SIBA when you have that specific backchannel use case, but you can use it based on 1.0 or 2.0.
Okay, so overall that depends on the implementation, how the implementation have been done in the enterprise, in the banks, right?
Yes.
Okay, thanks.
So that would be a question to Takashi. Did you take a look at FAPI 2.0 already?
I've already investigated FAPI 2.0, and I've already tried to implement some features for FAPI 2.0 or to implement and contributing to FAPI 2.0. Also, I would like to tweak this new FAPI 2.0 security profiles on by my proposed model, ABAC security profile model.
Excellent. So what is also probably interesting for you is that the FAPI working group wants to create a document that gives implementation advice. And part of that advice could be exactly what you have been addressing today, namely how to use multiple profiles or even multiple versions. So it might be interesting for you to follow that work or to give input to that work.
Yes. I'm also interested in. I'm also interested in point. I would like to follow this work.
Excellent. Are there any other questions?